at RubyKaigi, like in 2015 or so, there was a talk of about making Ruby faster. That was the last keynote at the conference, and that was very inspiring keynote because even Phoenix discussed how Ruby could be faster if you compile Ruby into the LLVM IR. LLVM IR is a compiler infrastructure that is used by, for example, the Clang C compiler or Swift or many other native modern languages like Rust. And LLVM is a powerful infrastructure that allows you to speed up a programming language if you just turn your programming language into their intermediate representation. And so they gave the presentation of how Ruby could be faster by just doing that kind of thing. That the idea that you can also convert the Ruby methods implemented in C into LLVM IR, so you can combine Ruby translated into LLVM and C translated into LLVM and optimize them together. And so that seemed like something we could do to speed up the Ruby language itself significantly. Like when I implemented the faster Hamo implementation, I already did everything I could do to speed up the Hamo language into the maximum of their potential. So if you want to make it faster than that, then you have to actually work on speeding up Ruby itself. So that's actually what I started doing. So the next year, I made a LLVM-based JIT compiler, actually. That's called LLRB because LLVM Ruby. And so that's a LLRB project. And I published it and sort of presented it at the next RubyKaigi and as a lightning talk. And in the same year, there was another talk that also was giving a presentation about the JIT compiler called MJIT. So MJIT was a JIT compiler that is developed with using the C compiler as a backend for making native code. So usual programming languages don't use C compiler when it's running for making the machine code, but it's a unique design. MJIT's unique design is when you call a Ruby method, you just spawn a C compiler process and let it compile Ruby code into C code, and then the JIT compiler rewrites the Ruby code into C code, and then the C code is then fed into the C compiler, and C compiler generates the machine code, and the MJIT dynamically loads the binary created by the C code and C compiler and rolls it at runtime and run it. So that's how MJIT worked. And the author of the Ruby programming language, Matt, liked the idea rather than integrating LLVM into the C programming Ruby implementation. So that's what they adopted in the first JIT compiler in the Ruby 2.6. Yeah, what was the question? That's I guess how I got into optimizing like compilers.
Interesting. I didn't know that it was because you started with Hamo,
Mm-hmm.
improving Hamo.